This is Aslan, and today I want to show you how you can construct a phase space of a complex signal in a 3D by using Matlab, and even how you can measure the fractal dimension of its plots in a complex shape by using box counting method. Okay, first of all, I here write a script, simple script that contains some sections, here 7 sections, simple sections to do that. And first one, as you know, for the clearing the workspace, command window, so on, to refresh your Matlab and computers. And in the next one, you load a complex signal, which I determined it here as a COP signal. It is one of the biological complex signals that there is. I show you here. Yeah, as you see, it seems really complex because it contains different fluctuation, as you see in here, big fluctuation by high domains and low frequencies. On the other hand, we have high frequencies, fluctuations by limited amplitudes. Okay, and for this signal we want to reconstruct its phase space. First of all, we need to measure and calculate the mutual information of this signal. Here I use mutual average information method. There is another method, but it's one of the best ones, but it's just a little tiny, so I just save it, and I get the trick here and just load it. As you see here, as a V, it has near 500 data, and in the next one, in here, we want to plot its phase space using mutual information and also calculate the fractal dimension of this signal. Okay, let's see. Because of the high processings, it's just a little tiny, as you can sense. Okay, it's the first leg, phase space for the first leg, as you see, and then you know it's like a linear shape, but by bigger legs it's go expanded, and here we have its signal. It's the leg, as you will see, and here we have fractal dimension for each leg and also mutual information that reconstruct the phase space. Okay, we are waiting to obtain to the here, which is the minimum of the mutual information, and we want to have a complexer shape. As you see, it's go more complex, and of course it's go more contraction. Okay, it will be faster and faster because of the low data, because by using bigger legs, the data and the samples reduct, and so it's go faster and faster, as you see. Okay, as you can see here, fractal dimension and mutual information are the part of a two-side. Usually when one of them go down, the others go up. And I myself like to use this kind of signal processing. Of course, it's costly, but there is lots of beneficials, such as high accuracy and good results that you see at last. Okay, as you see, the fractal dimension is go bigger and bigger, and shape will be go more and more complex. As you see, there is an information in contraction and expansion of this phase space that we can extract as a feature to determine, to predict a biological expand in the future, for example, to predict seizure or to detect a disease such as Parkinson or something, some other things you can use it. Even in other projects, other non-biological projects, you can use this strong method. Okay, it's really timely to measure for all sample. What I want to show you next is how to measure fractal dimension. As you see, for measuring the fractal to measure or to calculate the fractal dimension, you need some K, that is the scales of growth, which is a famous formula, log of the mass to the log of the scale, that the result is estimate the fractal dimension. As I said, it's a function that I wrote in Matlab, and there's an option here. You can use last interaction, last iteration, that you can show the last iteration, and you can just remove it and just get the FD as a fractal dimension, and also you can use it for all iteration. Typically the chi is equal to the 10, but here for this project, because of the time limitation in time that we have, I just got it in a 3. Okay, okay, it's I just want to tell you how fractal dimension work. Okay, here we have some plot for some cars. For first car, we have a nonlinear curve that will be shift to the linear curve, linear lines, estimated linear lines. That slope of this line is the fractal dimension. But how? Here for the first K, for first scale factor, we had near 4 touched boxes. As you can see here, for the first K here, we have a box and only one box, as you see here, it touched. And for the second scale here, we have near 7 touched box. In the second scale, now we have 8 box, and 8 of them are touched. Up to here, the dimension is 3. And for the next one, the scale factor will be 3. That, as it's see here, there is 27 boxes, that some of them are not touched. For example, here, one of them, it can be sensed, not be touched. It's not easy to see for the bigger car, and so it, because of the logarithmic ratio, you can shift it in a linear shape, as you can see here, and finally you can obtain easily the fractal dimension of the string. It's not really accurate because of the k. It should be 10 at least, because as you said, it's tiny, and because of the limitation of time, I just use it by 3. Okay, nice to see you again. Have a good day.